Hey everyone! So, if you've ever had to manage cloud infrastructure, you know the feeling, right? You spend hours, maybe even days, clicking around in a web console, tweaking every little setting, and you finally get it. It works. And then someone asks you to do it all over again. It's that journey from total triumph to absolute terror. So today, we're going to talk about how to get away from all those manual clicks and move to repeatable, reliable code.
And, nothing sums this up better than a comment I saw on Reddit. Zaitin says, you take 3 days setting it up by hand, clicky on the UI. Great, it works. Now, do it again for production. And that little laughing emoji at the end, it's just so perfect. It's funny because it's painfully true, and it perfectly frames the exact problem we're going to solve.
This whole manual process has a nickname, People jokingly call it ClickOps. It's where a lot of us start out. But as that Reddit comment makes so clear, it's a way of working that just completely falls apart the minute you need to scale up, or repeat something, or work with a team.
Let's really break down this ClickOps nightmare. First off, it's so slow, and it is just begging for human error. Did you remember to check that one tiny box in production that you checked in the dev environment? Who knows? Which leads to the next point. You can't guarantee consistency. It's impossible. And maybe even worse, there's no paper trail, no history of who changed what and when. So if something breaks, good luck figuring out why. It's like building a really complex house without any blueprints, and then being asked to build the exact same one again from memory. You're just set up to fail.
So, what if we could create those blueprints? What if we could start treating our infrastructure, all our servers, our databases, our networks, the exact same way we treat our application code? That is the big idea, the fundamental shift in thinking we're diving into.
And this idea has a name: Infrastructure as Code, or IAC. The concept is actually really simple, but it's incredibly powerful. You manage and set up your entire tech stack using configuration files, using code. So instead of clicking buttons in a UI, you just write down what you want the end result to be, and an automated tool makes it happen.
Now, within IOC, there are two main ways to think. The first is imperative. That's like giving someone turn-by-turn directions. Turn left here, drive 2 miles, take the third exit. You have to spell out every single step. But the other way, the declarative approach, is so much more powerful. That's like telling your GPS your final destination. You just say, I want to end up at 123 Main Street. You don't care how it gets you there, you just care that you arrive at the right place.
And the tool that has really become the gold standard for this declarative approach is Terraform. This is the hero of our story today. It's the GPS that takes our infrastructure blueprint and turns it into a reality. So what is Terraform? Well, in a nutshell, it's an open source tool made by a company called HashiCorp, and its whole purpose is to let you build, change, and keep track of your infrastructure in a way that's safe, efficient, and totally repeatable. Okay, so that's the big idea. But how does it actually work? What does it feel like to use it? Well, the core workflow is surprisingly simple. It really just comes down to a few key commands. It goes like this. First, you type Terraform init to get your project ready. Then, the most important step, Terraform plan. This is like a dress rehearsal. Terraform shows you exactly what it's going to create, change, or even delete, but without touching anything. It's a preview. If you look at the plan and you like what you see, you run Terraform apply, and boom, it builds it all for you. And then when you're all done, Terraform destroy, tears it all down. It's this simple, predictable cycle.
Now, the secret sauce behind all of this is something called the Terraform state file. You can think of it as Terraform's brain, or its memory. It's just a file that keeps a perfect record of everything it's managing out in the real world, and it maps all of that back to the code you wrote. This file is how Terraform knows what it's responsible for.
Okay, so if you're just messing around by yourself, keeping that state file on your own laptop is fine. But the second you start working with the team, that is a huge no-no. You have to use what's called remote state. You store that file somewhere everyone can access it, like in an AWS S3 bucket. This gives the whole team one shared brain, and that enables a critical feature called state locking, which makes sure two people can't trip over each other and make conflicting changes at the same time.
So, when you put all these pieces together, the code, the plan and apply workflow, the state file, it's not just a small improvement. It fundamentally changes how teams build software. It solves every single one of those ClickOps problems we talked about at the beginning.
And there's an analogy for this that I just love. It came straight out of that same Reddit thread. It's perfect. Using Terraform is like having Git for your infrastructure. Just think about that. All the amazing things we get from version control for our code. A full history, code reviews, collaboration. You now get all of that for your servers and databases.
And this unlocks some game-changing benefits. You get true repeatability. You can spin up an identical copy of your production environment for testing with one single command. You get versioning. You can look through your Git history and see exactly who changed what, when they changed it, and why. You can automate the whole thing, plugging your infrastructure right into your CI/CD pipelines, and my personal favorite, the code is the documentation. A new person can join the team, read the Terraform files, and understand the entire architecture. It's amazing.
But wait, there's more. Here's a really huge differentiator from tools that are tied to a single cloud, like AWS CloudFormation. Terraform is cloud agnostic. That means you can use the exact same language, the exact same workflow to manage resources across AWS, Google Cloud, Azure, you name it.
Let's make that real with an example. Look here. The goal is the same. I need a place to store files, what we call blob storage. But the way you do that is different in each cloud. With Terraform, you don't have to learn 3 different tools. You just declare what you want, an AWS S3 bucket, or an Azure M storage container, or a Google storage bucket, all using the same consistent language.
And as your setup gets bigger and more complex, you don't have to just copy and paste code. You can package your infrastructure into reusable components called modules. Think of them like functions in a programming language. You could create a module for your company's standard secure web server setup, and then everyone can just reuse that module over and over, ensuring best practices are followed everywhere.
So yeah, Terraform absolutely changed the game. It turned infrastructure management from a manual, error-prone chore into a legitimate software engineering discipline. But, the story isn't over. The IAC world is always evolving, especially now with open source forks like OpenTofu emerging. And it leaves us with this really fascinating question to think about. Is the future of infrastructure going to be one single tool that rules everything, or will it be a more diverse landscape of specialized interlocking blueprints? It's going to be interesting to watch.